All right. One more thing that I had in my notes that I had forgotten to mention, I've had lots of allergy medicine today, is that in your textbook, it does mention using Bonferroni as your post hoc analysis. And I just wanted to show you that one, you can do Bonferroni in PSPP, and you also get the same result in terms of which ones are significant. The only thing that differs is the magnitude of significance that shows up. So let me show you what I mean. So let's come back down here to analyze, compare means, Way ANOVA. We still have our class as our factor. Remember, independent variable. Our test scores are dependent variable. But now when we do post hoc, we're going to click Bonferroni and Tukey. Go to continue. And now let's go to OK. And now when we pull up this, you're going to see two different layers. Because you can tell it to, if you wanted to do all of those post hocs, you could. I mean, you can tell it to do as many as you want. But what you'll see with Bonferroni and Tukey is that we still have, if we look up here at Bonferroni, we still have that the classical music is different from both fan favorites and ambient. And we still have that there's no significant difference between fan favorites and ambient, right? We look at fan favorites to ambient when we come over here to this line. And just in case that wasn't clear how I'd set that up, so this first column is representing this versus one of these. So if we want to see the difference between classical and fan favorites, we trace this all the way across, a mean difference of 3, a standard error of 0.82, and a significance of 0.003. If we want to see the difference between classical and ambient, this would be like a diagonal line coming right here. We trace this all the way across, mean difference of 2.7, standard error of 0.82, significance of 0.008. Fan favorites to ambient, same thing, diagonal line all the way across, and it's not significant. So what you'll see is we have the same variables or the same comparisons that are significantly different versus not significantly different. But what you see is that whereas with the Tukey, the 0.003s are the same. You have a slightly less power of statistical significance on Bonferroni with the 0.008 compared to the 0.007. And this one, the Bonferroni fan favorites to ambient is a 1, meaning like not even close, right? Like as far away from statistically significant as you can get, no difference, compared to the 0.929. So this one is going to be making estimates, the Bonferroni is going to be making estimates that are a little bit more conservative than your Tukey. If you were to get something that was right on the borderline with Bonferroni, it might show as significant on Tukey, but it's unlikely. Again, going into the exact differences of them is beyond the scope of this class. Some people recommend one versus the other depending on how many groups you're comparing. There's a lot of statisticians that say, if you're having more than 4 or 5 groups, at that point, the sensitivity of different tests is going to make a difference in how your results come out. But again, for the purposes of this course, you can use either one. Your textbook does discuss Bonferroni. I just, in my training with analysis, all of my advisors preferred Tukey. They all use Tukey. That's what I learned how to use. It's one of those you stick with what you know kinds of things. But that's more detail about how to read this chart and know exactly where you're going with it. And also just so you can see the breakdown of these two of where the numbers differ, but it does not differ which ones are statistically significant and which ones are not. And as you can see, the mean differences and the standard errors are all identical, right? Because the calculations for those do not change based on which method you're using. So that is what they both look like. Again, if you want to know the differences, I'm happy to send you some resources about that, just for your own exploration. And now we will move on to factorial ANOVAs.